Hi, this is a summary for Thursday's lesson, May 28th, and answering a couple student questions as well. So what we tried to do is go through the history of the atom, the basic structure of the atom, and a couple features from the periodic table. Okay, so closer to the end of the lesson, we talked about the different models. So technically we can learn these older ones, okay, but these four are the most common ones that are taught. Okay, Dalton's model, it has to do with the billiard ball, J.J. Thomson, Ernest Rutherford, Niels Bohr, and then our new ones are nice to be aware of, okay, because that's what's actually happening today. And but I mean, your textbook was written before this stuff was invented. Okay, so you don't have this assigned to you this year to do a timeline of the history of the atom. Okay, but I would recommend you look at them. Okay, so people think this is the model of the atom, but it isn't. Okay, that's Rutherford's model of the atom, but we've gone past that now. It looks cool as a graphic for t-shirts, but ideas of what the atom looks like over time has changed. This was the plum pudding model, okay, sometimes called the raisin bun model. Okay, so there's some pages in your textbook, and we haven't gone through these ones yet, but we did look at this picture here. Okay, so we went through what alchemists are, Democritus, we kind of skipped over Lavoisier, okay, and moved into a PowerPoint about it, okay, this one here. So if you want to open that up, that'd be a good idea, and take a quick look at what Dalton, Thomson, Rutherford, and Bohr did. We did not go through any of these videos, particularly the song or Rutherford's experiment, but those ones would be important for you to take a look at so that you're familiar with the concepts. Okay, there's some Google Translate content here from past years. Not perfect, but I mean better than nothing, right? The other item we focused on, besides history, specifically Dalton, Thomson, Rutherford, Bohr, was what, there's the chart, okay, using a chart to help us identify the atomic mass, number of protons, neutrons, and electrons of a substance. Okay, so we have different elements. Added radium here for Tim, who really wanted radium in his example. Okay, because I mean it is one of the more fun elements for sure. So we took a minute seeing what we could spell, right? There's lots of fun t-shirts and jokes out there about what you can spell with the elements of the periodic table. Okay, but some things you can't actually spell. Let's see, chemistry, get it, with the gifts of the Holy Spirit. Some things you can't spell because you don't have the letters for it, right? Like these people cheated and they just kind of put white out on some of the letters, okay? But you can't do that, right? You can only use the way they are. So we took a quick look at this to see that the orange is nonmetals, okay? Purple is metalloids, and green is metals, but we haven't really talked about what that means yet. Okay, for now we're examining more what this atomic number means. Okay, there's a number in the top left of every single one of these boxes, the elements, which actually goes up to 119 now. That's, you know, we've made some progress there with discovering more elements. The symbol, that's the letter. The name of it is typed with a capital letter at the front. Some of them are named with Latin words, some of them named after people, like we have Americum, there's a name Curium, like Mary Curie, there's Californium, Einsteinium, Mendeleev, who's the guy who helped organize, who did the most work on organizing the periodic table in the first place, Lawrencium, okay, but really the ones you need to be most familiar with is numbers 1 through about 20 or so. Okay, yes, we do use some of these other ones, particularly chromium, iron, cobalt, nickel, and copper and zinc in our work. Okay, but if you want to memorize, P is for what, N is for what, Cl, F, and E, neon, fluorine, argon, okay, then these top 20 would be what you want to take a look at. Okay, so using this periodic table of elements, we filled in this chart together. Okay, so I asked for an example, and we got radon, zinc, magnesium, manganese we did at the same time to recognize that number 12 and number 25 are actually different elements, even though they look very similar, manganese and magnesium. Okay, so you'll notice that these numbers are all the same. The amount of protons, electrons, and the atomic number that you have here is all the same. Okay, so protons in the nucleus, 86. For radon, 86, 86. The atomic mass is this number at the bottom. Okay, so in radon's case, we're looking at number 86 here. That's 222. Okay, so what the neutrons are is what else is in that atom that gives it the mass. Okay, so neutrons don't have a charge, but they do have an impact on the mass of an atom. Okay, so to find out what that is, how many neutrons you have, you take the atomic mass and you subtract that by the atomic number. Okay, so to find out how many neutrons you have in radon, you go 222 minus 86 is 136. Okay, then when you see a decimal, you say, wait, I don't want decimals. Okay, so you round that to the next, you round it off. Okay, so 65 minus 30, okay, which you can actually type in a formula in a Google Sheets, okay, is 35. Okay, 24 minus 12, 12. 55 minus 25, 30. Okay, 226 minus 88, 138. Okay, so we need to be familiar with those numbers there. Ion charges we're going to get to on a different day. And that's as far as we got. I would like, if you don't mind, for you to take a look at these two new videos that I added. They are right here. I just have to push refresh. Okay, it has to do with the uncertain location of electrons and how small an atom is. So two of my favorite video producers, Ted Ed, okay, and then Kurtzagast. They both have similar content, talking about how particles move as a wave and also as a particle, or the particle duality of matter. Okay, matter can be as a particle or a wave. So I would recommend you watching both of those, please. Okay, so this one and this one, which can both be found here. I'll link them directly for you in the email I send. Thanks, bye.